Hi everyone, I'm Nicolas, and today I present project number 2, which is TReC, Trust for CAI for social media deepfake detection. Okay, so let's start with some context. As we all know, today with the improvements,
I think we
don't
haven't
see
shared
the back.
Yeah, we haven't shared the.
So as I said, let's start with some context. So as you know, today with the recent advance in Gen AI capabilities, we know that deepfakes have become a major issue in our society, essentially with fake news, public opinion manipulation, misinformation. Deepfakes essentially erode people's trust in what they see. We also know from the literature that deep learning-based detectors that appear to work very well in the lab may in fact break in the wild because of some input manipulation, such as compression, resizing, also adversarial manipulation that essentially degrade the performance. Even worse, we also know now that model confidence itself may be attacked and manipulated by adversarial attacks. So one can either inflate or deflate model confidence to either bypass human verification or, in the opposite, flood any kind of fallback policy that may have put in place. So this is the big picture in which TrustFake is framed on. So essentially, TrustFake is meant to build detectors that stay honest, robust under perturbation, calibrated also, and enable human-in-the-loop content moderation. So, okay. So the core objective of project is to build a robust deep classifier that essentially takes in input social media image, which may be adversarially perturbed, and produce as outputs robust prediction and also robust uncertainty estimates. The idea is then to feed those two robust model outputs to some selective decision layer that essentially let the model abstain when the uncertainty is higher than some threshold. There are three different scenarios. For instance, if the probability of the fake class is low and the uncertainty is low, then the image should be automatically validated and published on the platform. If the uncertainty is higher than some threshold, then we should abstain. The model should abstain from giving a prediction, and some fallback policy, such as human verification or validation, should be triggered. And when lastly, when the fake class is high and the uncertainty is low, the image is, of course, automatically removed. So in terms of methodology, we choose to divide our project in 4 different work packages. So the first work package is deepfake detection, the deepfake detection framework itself. So in this work package, essentially, we train our detection baselines. So it will start with data pipeline, with data processing, model training with the task pipeline, and most importantly, the evaluation pipeline. So here we need both classification metrics and also uncertainty and calibration metrics, because we need to assess the quality of both our prediction and our uncertainty estimates. In work package 2, adversarial attack for predictive confidence manipulation, predictive and confidence manipulation. Essentially, we'll try to explore different ways to degrade all the performance obtained from the previous work package. Here, we plan to explore adversarial attacks that target both the prediction and adversarial attack that targets also model confidence. In the work package 3, essentially, once we will have identified the model vulnerabilities, we'll try to make the model more robust and harden them using adversarial training algorithms. And finally, in work package 4, we'd like to set up an end-to-end demonstrator showing the whole pipeline with our findings and results through an interactive web interface. So more concretely, we plan to use the seedset dataset as our project dataset. So the seedset dataset is a dataset comprising 300,000 social media images coming from different sources, like open images, Flux, or also image from latent diffusion edits. For baseline, we plan to use ResNet detectors. In the uncertainty layer, we'd like to go beyond standard softmax uncertainty. We'd like to use MC dropout or deep ensembles. And for the robustness, we plan to use standard adversarial attacks such as PGD or auto attack, but also explore confidence-based attacks, which is new attacks that we still not have already explored. And lastly, yeah, so for now the team is composed of myself and Ahmed Baha, which is out there. So we both come from Multitel. We have expertise in computer vision and trustworthy AI primarily. And yeah, in terms of expertise thought, so we plan to use PyTorch. So there will be PyTorch coding, standard deep learning, adversarial machine learning, and uncertainty is of course a good thing. And also prototyping. So here more software developers profile are also highly appreciated. But mostly we are looking for motivated people. So if you think your skill doesn't match what is written here, but you still want to explore this fantastic topic, which is trustworthy AI, really feel free to reach out. So yeah, that's it for me.
Okay, great. Okay, great. Do you have any questions for Nicolas? I just would like to know what's the skill you don't have in your team right now and you're expected to have in your team?
That's a good question because we have all the skills. I mean, I'd say that everyone is welcome, and we know about adversarial attack. We know also about uncertainty, but I mean, new people having other opinion on that and giving new insight on that are of course welcomed. I'd say that also, yeah, for the prototyping part, this is maybe the weak part of our team right now. And yeah, but I say it's an open project, so feel free really to reach out.
Thank you.
I have a question.
Yeah.
Yes. Are you going to explore watermarking in the process?
Sorry?
Are you going to explore watermarking images?
Yeah, not at all. I mean, it's really important not to mix up the two. So, of course, watermarking are a big deal right now for deepfake detection, but here we really use deep learning-based classifier to differentiate between natural and fake images, and not considering watermarking at all, which is another way, I agree, to identify deepfakes and AI-generated content. But here we are like using the assumption that the image we will try to classify are not watermarked, of course.
Okay. Thanks.
Just to let you know, we have a master thesis with Ronnie. A guy is producing an online server with different detector of fake images, but based on the fact that when you use deep learning to create an image, you have some traces on it. I don't know if you know the word of Mr. Lipa, I don't remember her first name, but there are plenty of things, and we have implemented an online server with those rules.
Okay.
So just to let you know, and it's at your service.
Okay, great. And is he participating to the summer research camp? Or?
We could push the guy to participate to this.
That could be a good thing. Yeah.
Kind of three layers. So you have the fingerprint, then watermarking, and then the classifier.
Okay.
So, but the Chinese guy, the Belgian guy with the Chinese name, is unable to speak Chinese. Exactly Chinese, but he's a Belgian guy, and he has done a very good job for a server with all those tools.
Okay, yeah. I didn't know that, so yeah, it's good to have a look into it. Okay. We had another question here.
Very quick last.
I think it's on the topic. Do you have some first idea on how to attack the confidence of the model, or is it just
So essentially,
Can you repeat or rephrase the question?
yeah, so the question is, if I understood well, do we already have an idea on how attacking the model confidence itself? So there's a bunch of paper about that already, and basically the idea, what I understood already is that, for instance, let's take MC dropouts. So we take the uncertainty comes from the uniformity of the prediction of all or forward paths of the models. So here the idea is that instead of attacking one prediction, let's attack all the prediction together and make them either uniform or not. And so it's like ensemble adversarial attack. So instead of attacking one model, you attack all the models at once, and you like learn on an adversarial attack that is optimized over multiple models instead of only once. So those are the ideas that also apply to deep ensembles. But yeah, this is really, I mean, I'd say the big part of the project is also to explore those kind of new attacks, uncertainty attacks.